Our cosmic neighborhood, the solar system, can feel quite familiar. We know its 8 planets: rocky Mercury, the gas giant Jupiter. We have sent probes to its asteroids. We have sent probes to its comets. Yet, beyond the orbit of Neptune, where the sun's light fades to a pale glimmer, lies a vast, dark frontier. It is here, in this cold and distant realm, that some astronomers believe a new world is hiding, a hypothesis born from strange and subtle clues. The primary evidence for a hidden planet comes not from what we can see, but from what gravity does to things we can. Far beyond Neptune lies the Kuiper Belt, a sprawling disk of icy bodies. Pluto, the most famous resident, floats there. Astronomers have discovered extreme trans-Neptunian objects, ETNOs. Their enormous, elongated orbits take them hundreds of times farther from the Sun than Earth. Instead of random orientations, a handful of distant ETNOs are mysteriously clustered together and tilted similarly. That statistical clustering suggests an unseen force shepherding them, orbital resonance, and a sidal alignment. The chance this happens randomly is very low, perhaps under 1%. Like corks on a lake moving in unison, these orbits point to a hidden gravitational current, perhaps a massive, undiscovered planet. Once the clustering was identified, Konstantin Batygin and Mike Brown at Caltech tested a bold idea with simulations. Left alone, the orbits go random. Add a distant perturber, a hypothetical 9th planet, and order emerges. A world 5 to 10 times Earth's mass on an elongated orbit could reproduce the alignment. The planet's orbit would sit opposite the cluster, gently herding smaller bodies into a stable, anti-aligned configuration. The model also predicted a tilted population, which subsequent surveys have found. Not rocky like Earth nor a gas giant, Planet Y would likely be a super-Earth or mini-Neptune. It might orbit every 10 to 20,000 years, ranging from 200 to over 1,000 AU. Formed among the giants, then flung outward, it would be a planetary exile, a relic of our violent infancy. Science at its best is a skeptical enterprise. The Planet Y case is exciting, but still circumstantial. Our survey patterns, where and when we look and how deep, can create bias. As the sample grows, clustering may fade, or persist. Another idea, the combined gravity of countless small bodies could mimic a single planet. More exotic possibilities include subtle deviations in gravity or an ancient stellar flyby. For now, Planet Y remains the simplest, most predictive explanation, and science will test it rigorously. To move from hypothesis to discovery, we need one thing: direct observation. We need to see Planet Y. Survey telescopes re-image wide swaths, hunting for motion. Even a distant planet betrays itself by a tiny shift over nights and weeks. Subaru, the Dark Energy Survey, and Pan-STARRS are charting the outer solar system object by object. A massive, cold planet should emit a whisper of heat in infrared. Spitzer and WISE data have been mined intensely. No detection yet, but we've ruled out Jupiter-sized worlds and narrowed the parameter space. Rubin's 8.4-meter eye and record-breaking camera will scan the southern sky every few nights. Tens of thousands of new objects will provide the definitive statistical test. and maybe the picture. Searching for Planet Y is like finding a needle in a cosmic haystack. Orbits and models sketch a probable path, but with big uncertainties. The likely region sits in the Milky Way's crowded glare, an astronomer's nightmare. Its motion is glacial. We may need to compare images months or years apart. The hunt is global and collaborative. New algorithms, archival reanalyses, deep targeted searches. Every empty patch constrains the possibilities and shrinks the haystack. Teams commit precious nights and compute to the most promising coordinates. Step by step, we close in on an answer. Discovering a new planet would resonate far beyond astronomy. It would echo Neptune. Prediction meeting observation. We'd measure its mass, size, orbit, test atmospheres, moons, and composition. Its existence would reshape our story of the solar system's chaotic youth. A distant massive planet could explain puzzling orbits and long-period comets. Adding a major member would change how we see our place in the universe. It reminds us our cosmic map is still unfinished. The search links us to generations who looked up and wondered. Extraordinary claims require extraordinary evidence. The burden here is high. The case rests on indirect statistics. We must capture Planet Y's light and motion. Until a photograph and orbit are confirmed, it remains a ghost in the machine. The community is divided, as science should be. Past planets vanished under scrutiny. Vulcan solved by relativity, not a new world. Upcoming surveys will decide. More etnos and stronger clustering, or not. If clustering persists, Planet Y becomes hard to deny. If it fades, we pivot to other models. Either way, we learn. Planet or no planet, science advances. As of late 2025, Planet Y remains a hypothesis. Powerful and predictive, but not yet a known world. Patient investigation, weighing evidence, challenging assumptions, pushing technology. This is frontier science. A new era of discovery in the outer solar system is beginning. Our map will either include a new planet, or the reason we thought one was there. The journey builds better telescopes, smarter algorithms, and a richer census of distant worlds. It's a humbling reminder of space's vastness and its secrets. We watch, we gather the light, and continue the search, the final chapter yet to be written.